Welcome back to the rest of our 2.2 notes on absolute value inequalities. So for absolute value inequalities, it's important that we have an understanding of compound inequalities because we're going to be using those in order to represent the solution set for absolute value inequalities. So here's our first example. If I think about the absolute values of x that would satisfy this inequality, where they would be less than 3, think about the numbers that would make this work, right? 2 is less than 3, 1 is less than 3, certainly 0 will work. But also -1, because the absolute value of 1 is 1, and that's less than 3. -2 will work, but what happens when we get to something like -4? Is the absolute value of -4 less than 3? Well, when I take the absolute value, we're going to get 4 is less than 3, and that's not true. So we're only going to have numbers between -3 and 3. So here's our solution set. So because of what we learned with compound inequalities, this can be represented by an AND graph. So we have all the numbers that are less than 3 and greater than -3. So this is an AND sort of compound inequality. So we can rewrite the absolute value of x is less than 3, the absolute value of x is less than 3, as x is less than 3 and greater than -3. So it's just rewriting an absolute value inequality. We're representing that same solution set using compound inequalities. So for less than, it's the same, it becomes this and compound, okay? So my little way to remember that is a less than, okay? You're gonna see that and in that mnemonic device there. So it's always gonna be in that form, right? Whatever this guy is, we're gonna put that there. We're gonna flip the symbol, flip the sign, and put that over there as well. All right, so let's do our other type of absolute value inequality. If I said the absolute value of x is greater than 2, what numbers are going to work? Well, 3 is going to work, but also numbers like -3 are going to work, because if I plug in the absolute value of -3, we get 3, and 3 is greater than 2. So we're going to get two sets here, right? We're going to get all of the numbers that are greater than 2, or numbers that are less than -2. So we have our solution set is an OR inequality. So our pattern here is that when we have a greater than absolute value, it's going to turn into an OR. So the way that we remember this is that it's a greater than. Okay? And this is always going to be in two separate inequalities with the word OR in between. So let's do some examples. We're going to start real simple with the absolute value of x is less than 6. So remember, we're going to do x in between. So it can be less than 6, and it has to be greater than -6. Okay? Since we're just working with x here, that one's already solved once we put it as a compound inequality. For x is greater than 6, we're going to have two parts. We're going to have x is greater than 6, or x is less than -6. So you can pay attention to how the symbol and the sign stay the same here, and then they flip and switch over here. Okay? And it's always going to follow that pattern. One's always going to be the same, and then it's going to flip the symbol, flip the sign for the other side. So in order to solve these types of inequalities when they get a little bit more complicated, like down here, we are going to pay attention to our rules from absolute value. So the first thing we need to do is to isolate the absolute value bars. And we're going to do that by adding 1 to both sides. We get the absolute value of x plus 6 is greater than 5. This is a greater than, so it's going to be an OR. So we're going to make two inequalities. So I'm going to take this stuff from inside my absolute value bars. X plus 6 is greater than 5, or x plus 6 is flip and change, less than -5. So when I go to graph this, we're going to get minus 6, which is x is greater than -1, or minus 6, x is less than -11. Remember, to graph, you just graph both pieces of an or, right? They're just going to go in separate directions for absolute value. All right, let's do this last one over here. Same thing, we have to isolate the absolute value bars. Be careful with this 3 minus 6, right? That's not subtraction that we can do. We have to undo each piece separately. So we're going to start by subtracting 3 from both sides. And then we have to divide by -6. And we get the absolute value of something, let's not worry about that yet, is less than 2. Okay, remember to switch your symbol as well as the sign. So if this is less than 2, we're going to put this stuff in the middle. We're going to put less than 2 on this side and greater than -2 on this side. So in order to solve, I just have to add 1, add 1, add 1. And we're going to get, I'm just going to write this over here, x is less than 3 and greater than -1. That will be my solution for this inequality. So all the numbers between -1 and 3, not including either one. Okay. So our last one here is a word problem that looks like it got cut off. But it says that 53% of people say that Mrs. Clinton will be the next president with a 4% range of accuracy. Write an absolute value inequality and a compound inequality to represent the range of percentages. So the first thing we might do here is just kind of think, right? If we start at 53% and we have a 4% degree of accuracy, that means it can go 4% up. So that would be 57%, or it can go 4% down, which would be 49%. Okay, so that's just kind of thinking, what does a 4% range mean, right? From there, we can make a compound inequality. So we know that 53, right, is one of these percentages. We're talking about the range that is between these numbers. So the way that we might represent that as a compound inequality is where x is less than or equal to 57, but greater than or equal to 49. Okay. And how did we get this? Well, we had to add 53 to both sides, right? So what we started out with was a -4 and a +4. So by adding 53, right, really what we're doing is we're doing 53 minus 4 or 53 plus 4. That was how we found our two numbers to begin with. So that was how we kind of solved it. So we're kind of just thinking backwards now. So our compound inequality is one of these. Our absolute value, right, is we just think this is a less than, so it must be x minus 53 in our absolute value bars is less than or equal to 4. So again, kind of working backwards, right? How would I get this compound inequality? It has to come from a less than or equal to absolute value inequality. So we're just working our way backwards.